This test. All right, hello everyone. Welcome to the stream. So I spent some time thinking about what I wanted to do this stream, and while I could vibe code a completely new diff reviewer for GitHub, since Graphites is paid and I don't want to pay for it, or I could try vibe coding some of the GHClerk stuff we talked about yesterday, or I could try vibe coding a new front end for TLParse. I decided I don't want to do any of those things. Instead, what I'm kind of thinking about right now is, hey, so AI coding is here to stay. LLMs are here to stay. There's going to be more and more code being written with LLMs. So what exactly do I think about this? So for example, yesterday we spent a bunch of time worrying about code review. What exactly does code review look like in this era of tons of LLM generated code? And I don't really know what I think about this. And so I just want to collect some of these thoughts and see if we can turn this into a blog post. I don't actually know where this blog post is going. So like part of the point here is to sort of figure it out. Okay? So we're just gonna like sort of map out the territory here. So it's starting in no particular order. So when we're doing AI coding with LLMs, one really good one is Greenfield. Doesn't matter if it's production ready. System is set up so that failure is not a big deal, or it's obvious when failure has happened. So examples of this are like one-off, well, less obvious examples. One-off investigations. This is troublesome because if the LLM steers you to the wrong result, wrong conclusion, it can be harmful. Okay, so obvious ones are like, random UIs for making, things easier, like visualizations, personalization features, that sort of thing. And the other one is like surgical fixes, especially in code bases you don't know well, or in languages you don't know well. I think this is kind of like how the LLM spikiness goes right now. Let's see, what else do I want to say? Okay, so why code review? I already blogged about this, but let's just think about this again. So why code review? So I think a lot of modern software engineering code review practice is kind of like it's actually just compliance related. At least where I work at Meta, we need to have two reviewers for every diff for compliance. Like we're just not allowed to do this because of like the FTC order and things like that. So I mean, the compliance it's kind of like voodoo. Like if I'm in a situation where I don't actually need code review, like maybe you don't need code review. I'm not sure. Let's also put down here, tests accumulating indefinitely, system invariance. That's something to think about. Okay, so let's see what else. Okay, so let's summarize a little bit of the gestalt. Like here are some things that I've seen people thinking about when talking about AI coding. So one is that a claim, senior software engineer, AI coding really hasn't changed the job at all. And why is that not the case? Well, it's because you're just what are you spending all your time on? Well, it's not really coding. Like you try to get some coding done, and certainly AI coding can increase the volume of like short one-off bug fixes you can do. But what is the job normally, right? It's reviewing other people's code. Oh, let's talk about code review topic again. It's about working on the system design, understanding system invariance, right? It's about communicating with the team and other people. And so, like, one of the things people worry about, what happens if you fire all the junior engineers, right? But the answer is, like, you're not going to fire all the junior engineers because even if you're maintaining all the agents, there is a limit to your scaling attention, right? And like I think the vibe coding for GHNBox is a good example of that, right? Which is that like it takes attention to vibe code it. Like, yes, I am generating code a lot more quickly and in a stack that I don't know anything about, but like, it still took a good 3 days, of concerted prompting, a few hours of prompting here, a few hours of prompting there to actually make it work. Like it's just, yeah, like clearly. So AI 2027 released their updated projections, and one of the things they updated was they were like, hey, how long does a coding agent need to be able to run autonomously for it to be considered like totally like basically replacement coding? And it's like something like 100 man years of coding time, which yeah, I had a funny Twitter interaction where I thought someone had misunderstood it, but I guess I misunderstood what they meant. And let's go apologize to the guy. The correct threshold for man years is here. Yeah, 130 work years, which it does seem like a lot. Like, I don't like, let's see. So 130 work years. So that would be like 13 people, 10 years. Like this is just really, really long. Like many projects just don't last that long. Like if I think one person, right? If I can have a single person working on a project and the model stays on track for 10 years, 10 years of like a really good programmer on one project, like if I could have an agent do that amount of work, I don't even care about how long it takes, right? Like take a year, whatever. But if it can stay on track for that period of time, like I would consider that like you have automated coding. But like what does it even mean to stay on track? And like this is like kind of, I think this is one of the like things that I really think about it's an alignment problem, right? But it's not that sort of lofty alignment problem of is the super intelligent AI going to kill us all? It's like actually a very, very simple problem, which is like, what exactly like does it mean for a like, and if we forget about coding agents at all, what exactly does it mean for a software project to be successful? Probably not just making money. I mean, like in the capitalist lens, right? Like if you make money, that's all that matters, right? Like that's the only. But we know there's negative externalities from just making money, and like I'd like to think that as a field we have a much more like we have loftier ambitions, right? Like what we want out of systems is more than just it can make money. Even though like I think the natural inclination of a lot of people is to like focus too much on sort of like the abstract lofty goals and they have to be bludgeoned into like, hey, but you make money. But I think there's a lot of like important surplus that the software industry has like produced from not just caring about money, not just caring about like race to the bottom, like actually caring about craft. Open source I think is a good example of this because there is no money to be made, right? Like where did all this surplus come from? Like it's because of the culture, and like I think this culture is important and is worth propagating. Flying Specs says the metric is however you interpret it. Lol. Well, I think they probably have a formal definition of it, but let's go ahead and check it out. So the question, so what exactly do they define this to be? Coding time horizon. Okay, so it's defined to be the meta coding time horizon. And yeah, I don't know. I guess they really are like going for super intelligent. Or this is just like, you're doing exponential, so you project this line out and you're like, oh, 100 years isn't going to take long, like, once it can do 50 man years, right? Like, oh well, that's just another doubling to get to 100 man years. But as I said, it's just, what does it mean for a software project to be successful? And this is a very complicated question, because once you get to that, like, the other thing that they point out in here, they're like, hey, we're kind of worried about the long-term meta horizon trend, because, hey, like, at some point, uh you're just not going to be able to measure it, because you're riding the exponential curve, and like, yeah, so we can do tasks that would take a week to do, a month to do, 10 years. How are you going to design a task that takes 10 years to do? Like, what does that even mean? Like, how do you build an eval suite for 10-year long software projects? Like, the software doesn't even last that long. Well, some software does, but what does it even mean? Right, what's the prompt for the Linux kernel? Build the Linux kernel. This is self-referential. Huge problem. All right, let's stop rabbit holing on this for a moment. Let's see. Okay, there's some other stuff that people say senior software engineers are about. So, they're also like, hey, senior engineers, about judgment. What is judgment? This is like similar to wisdom. It's like, you know, yes, you could do it, but better not to. Senior engineers about, trade-offs, right? Like, you could do it this way, you could do it that way. There's a trade-off. Which trade-off do you make? This is something that, like, it's very funny when you ask an LLM. An LLM will happily, like, when you ask an LLM a design question, it will happily go ahead and say, oh well, you could do it this way, you could do it this other way, and like, here are the trade-offs, and I think you should do this. But I, like, while I find this kind of design thing useful, by the way, I want to no trade-offs. Why I find this kind of design discussion useful, I can never trust the LLM to, like, actually make the decision, because there are things that I just haven't put in the prompt, like context that I know about, that better helps me understand whether or not I want to trade things off, right? Like, the LLM's determination is only as good as the prompt I write. So if I write not enough information, then the LLM, there's no way it can come to the right conclusion. Flying aspects. AI would be super intelligent when it can hack out a piece of code and then create a dependency so it doesn't get replaced by better AI. That's super intelligence. Yeah. Ha 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 ha. So, and another thing people say is senior software engineers is, like, it's about intent, right? Like, so prompts are kind of that. Prompts are verified intent, right? When you just have code just does what it does. Like, it doesn't want to do something. Like, whatever the code actually wants to do, the intent of it, that's, like, implicit most of the time. And sometimes it's, like, not even death of the author type situation. It's not even like something the original author of the code even knew was going to be used in this way. It just turned out, like, when people started using it, they were like, oh, this feature is useful. I like using it in this way. And let me think. uh Yeah. So like basically all of these things right now are things that you would like say, hey, this is what you put into the prompt. This is all about like, why are we doing this? Like how are we going to do it? What are we trading off? Right? Those are things you would typically tell the LLM. And it's difficult to understand how the LLM can like make these decisions for you because like yeah, like so this is a lot about like what is intuition, right? Intuition is the distillation of an extremely high dimensional space into a feeling, oh, we should do, right? And like half the time you can't even say why it is that you think we should do X or Y, right? Like it's just there's a lot of things going on. Some you are only subconsciously thinking about, and then that's why you make a call one way or another. And so like there's no way I cannot write that high dimensional like mental space into the prompt. So like what, right? So this is like kind of like related to the like embodied AI continual learning problem, right? Which is that like you kind of long context, right? Like the only way for the AI to actually like get this information is if it can operate in the real world, if it can actually like have the experiences, have the like interactions with the customers, the users that actually like let it build this high dimensional space that like says what you need to do, and it needs to like have enough context so that it can like keep it all, or you need to have solved continual learning so that like it doesn't forget about the things that it's learned, right? And like I mean I think a big part of the like AGI question is whether or not you think like this is going to be solved under the current regime, right? And the people who are very, very joyful about the prospect of hitting AGI, it's all about compute, right? Like I'm happy to bet that compute is going to keep going, but like is compute going to solve this? Flying Spec says, I'm going to the loop for an E5 role. I hope I can work with you folks at PyTorch. Thanks. I'm glad to hear it. Lots of the AI labs have been poaching PyTorch folks recently. It's kind of a pain, honestly. Ugh. Okay, where am I going? So, do I wanna go down this rabbit hole some more? I kind of do. What is going on? Why? Hmm. I guess I don't. I guess it's not useful worrying about this. Like, does compute solve this problem? Who knows, right? Like this is a like, oh, you can run experiments faster, and that's why you'll more likely luck out on continual learning. But like, yeah, you know, another like analogy that I have in my head is of MIT Mystery Hunt. So MIT Mystery Hunt is this big puzzle hunt they run at MIT, and that's just there's a lot of puzzles. You solve the puzzles, they unlock more puzzles, and they get more and more complicated until the end, and there's a big final puzzle, and you solve it, and then you win the hunt. And one of the interesting things that happens is when you like they usually like tune the hunt so that it is solvable, but sometimes they can get it wrong, and sometimes the hunt goes long. And the other thing is that like when you look at the top teams and the trajectories they get there, they sometimes get stuck, right? Like they're like blasting through the problems, and then there's a bottleneck. There's like a problem that must be there's a puzzle that must be solved to progress on the meta, and they get stuck, and they get stuck for like 12 hours or something. and like, you know, they're just flatlined there, you know, and then, you know, the other people are catching up, steadily solving puzzles. And like, I think scientific, like, one of the things I think is the reason why MIT students really like Mystery Hunt is because it like has a lot of the same characteristics of scientific discovery, which is that, you know, the way these puzzles work is that you don't know anything about them. Like, it's just some stuff. And you're like, you know, working through the data, trying to figure out, you know, what's the underlying pattern, like what exactly is it that the puzzle is asking you to do. And it's very, very similar to the process of scientific exploration, right? Because there's no one telling you do this and then it will be solved. It is just like, hey, you know, you need to make sense of the data and figure it out. And so like I tend to think of Mystery Hunt as like the scientific process like distilled into like a very, you know, like a small bite-sized package that you can finish in 3 days. Well, the top teams can finish in 3 days. In any case, right, what you can see is that yes, there are bottlenecks, and yes, like, you know, we take a slightly wrong turn, and then there's like this problem that needs to be solved. And even when we know the problems are solvable because there was a human designing the problems, you can just get stuck. And we don't even know if the problems that are happening here are solvable, right? Well, okay, we know continual learning is solvable in principle because like humans have solved it, and so like, you know, it's like, oh well, you know, in the worst case scenario, you can just reproduce the human brain, you know, but okay. So the bet I'm going to make, and for the rest of this essay, is I'm going to bet that this problem is not close to being solved, and it'll be interesting about, you know, what do you expect to see that makes it closer to solving this problem, right? And I like definitely think that like the problem can be solved in a one-off way. From domain to domain, like you kind of like, you know, draw out a domain. And you're like, well, this is the kind of domain that like I need, and then you set up all the systems so that they can start hoovering up the data inside this domain, and like, you know, set up some like domain specific solution for the continual learning problem, and then you get the shape of things, and then you like solve it. Financial markets like this, maybe not though, right? Like at the end of the day, like there's a lot of things you can learn just by looking at the ticker numbers, but eventually it's all about the world, right? Like this is like, you know, the algorithmic traders, right? They're looking at the news feeds, so someone can spoof the news feeds, and then they're like, oh, you know, the stock's going to go down because there's some bad news. No, someone just spoofed the news feed. But like you need to actually, like, sometimes the information you need is you have to like schlep out to like, you know, some random city somewhere and like go to the election poll and like count the number of people, and then like be like, oh, you know, this means I get a 10-minute edge on this thing. Like, yeah, real world's big, messy, complicated, you know. But yeah, I'm kind of rabbit holing here, but it's kind of fun to rabbit hole a bit. So I hope y'all don't mind. I'm thinking about PyTorch. Let's think about PyTorch. What about PyTorch? So this one's very close to my dear heart, because this is what I do all day during the day. And let's also talk about, what about superintelligence research? So I made all these claims about like the real world, and what exactly is the claim that I'm making about PyTorch as a project? And there's lots of domains you can slice out, actually. And maybe these are solvable. What does it mean for PyTorch to be I first? What does it mean for a library to be first? So when you think about like the library, some of the obvious stuff that pops to mind is, PyTorch is, a lot of it is about API design. A lot of it is about compositionality. They're talking about API design. This is sort of like, it's because if I'm vibe coding an app, I don't really care about like how all the internal pieces are put together, right? Like the LLM can pick for me, and in fact it's better if the LLM picks, because the LLM will pick like a sort of organization that makes sense to it, the LLM, and it'll be more easy, it'll be easier for it to find things. But when I am designing an API, this is not, why is the compiler API so terrible? LuaTorch is very historical. Okay, so what I was going to say is, but if you're designing a library and make it like, you really do want to sweat out the details of the API here quite a lot. And like one claim is part of what made PyTorch very popular is its API design. But there's also another sense in which we didn't really do all that much API design. Like, let's just think about it, right? When PyTorch was first written, it inherited most of its API decisions from LuaTorch. So there were some like good decisions we had to make. There's some good decisions we had to make on how to translate some of the Lua ideas from into Python, but in general, like, most of the APIs were lifted from Lua. And so there's this very long history, like, all the old versions of Torch, which PyTorch is inheriting from. And separately from that, we're also inheriting a pretty long tradition from NumPy. And if you look at JAX, actually, right, JAX doesn't have a API of its own. It just says, hey, use, JAX NumPy, and that's how you get all of your operations. So like, there's a sense in which we don't do very much API design. And I think about the like arc and history of PyTorch, like, where we spent a lot of like elbow grease and sweat, as developers of the library. What I think about the compiler. The compiler was like, also compile APIs are terrible, but like another thing, like, what did PyTorch spend sweat on? Compilers. We definitely sweated a lot about AutoGrad, right? Very important innovation, very important for making sure eager mode worked, like very, very important to the project. We sweated out the C++ library, A10. That was Zach DeVito. Zach did it in 2 weeks. Amazing. And with it, CodeGen, open registration, custom ops. We sweated a lot about the C++ Python divide. Trade-off between overhead and ease of changes. We sweated out crossing all of the hardware updates. This is one of the reasons why like PyTorch actually does need to be a living project. It can't just be done, because like the underlying hardware we're interfacing with is constantly updating, and then we have to update our library. What do we invest a lot in? And like, I think extensibility. This relates to compositionality, right? Like, so there's a bunch of subsystems, right? First AutoGrad, then VMAP, Torch Dispatch, etc. Making sure they all compose together, like that. We spend a lot of time and effort and design thinking on it. Oh, and don't forget about distributed. And this one's pretty interesting because there's been like the eager APIs, especially. And in particular, I think the like distributed API design problem quite difficult. And like, it wasn't like, for example, when the project started, it wasn't obvious that dtensor was actually like a really important way to do it. And like both JAX and PyTorch, well, maybe converged is too strong a word for it, but Jack's definitely like, I remember when Wan Chao was like working on the first version of DTensor, Horace told me that, you know, he didn't really believe in it. And now he does. But like, you know, back when it was first being designed, he didn't really believe in it. What does it mean for OSS to be AI first? So historically, being OSS is good because you're in the pre-training set, right? PyTorch being very popular means that LLMs know how to write PyTorch. Maybe not very well, but like certainly way better than, you know, some obscure library. And we get lots of issue reports. So this is more like the community self-support, like, I think. Like just having a lot of people means a lot of people can talk to each other and figure out how to solve their problems. And you know, OSS pull requests, usually small, targeted, fix this particular thing that is affecting me. Someone actually took the time to like understand the code base and do it. And like, I historically, especially before my second parental leave, I used to merge lots of PRs. Like basically, like, you know, my job was basically like looking at them and be like, well, you know, I don't necessarily have all the context about the code in question, but like, you know, it seems reasonable. It doesn't seem harmful. Like it is tested. And you know, I'm going to stick my neck out and like let you do it. And then there's some places that you kind of learn are very, very difficult to make changes to and you want to worry about. But it's generally nice to like spend a little bit of time and facilitate people doing all sorts of random things that aren't on your roadmap, because some of them pay off. Like torch function was done externally, huge impact, right? This was like, we didn't really understand why NumPy had done array function, and you know, our NumPy consultants at the time had done it, and it was like, it's a big deal. I mean, we haven't talked about AI at all, but like, I'm just kind of unpacking my thoughts on this matter. Streams are very quiet. Feel free to pipe up anything. Like, I'm just thinking out loud. Where do I want to go with this? So one of my questions is, yeah, so this is an earlier question I put. Well, what's the point of code review? Like, can you have a library set up where there isn't code review? What does that mean? So some of the like immediate thoughts that popped to mind is, you know how Go has that very ugly versioning scheme where you never break BC. Maybe this is a baby. The idea behind Go is you never break BC. You only ever make, you know, like V2 versions of API. Like basically you have this, like you just have this giant. Hickey had to talk about this against versioning, something. Yeah, against semantic versioning. I wrote a blog post about this. Oh, I'm actually probably thinking about Hickey's thing. Basically, like one of the problems we have in PyTorch is like once we add an API, we're like signed up to like maintain it forever, and it's very, very difficult. And it's very, very difficult to stop because like we value not breaking people's code as much as possible. And so like, and we also value, well, So like for example, torch.jit and torch.compile have a very, very funny like inversion of meaning, because torch.jit, the Torch script compiler, really is a traditional ahead of time compiler where you're compile like parsing the like Python syntax and turning it into a ahead of time compiled object. And torch.compile is a just-in-time tracer in Dynamo that like traces a straight line code only. And so we've actually inverted the naming here. Like we should have called our thing torch.jit, not torch.compile. And we didn't, because torch.jit is already taken. And even though we tell everyone that we're not supporting torch script, that's not, we're not going to get rid of it. We're not deleting this code. And so like we're just kind of stuck here. And like I did, Nikita and I often talk about this, and we're kind of like, you know, hey, well, it's not Nikita, but like, hey, if there was an easy way to offload features into third-party repos, best effort, maintenance, right? Like for example, many features are done entirely in Python, right? And if you just move them out when you're like I don't want to maintain this anymore, and then like, you know, you just move it from the repository, we don't have to run CI. Main problem is dependency tangles. Now, that's a very important thing to think about. All right, so so an example of this is FSDP1. So FSDP1 is actually very well self-contained, right? It's a Python NN module wrapper class, and there's not really anything that depends on it. Oh, well, I mean, if you're a training framework, you're going to depend on it. But from the library perspective, we don't depend on FSDP1, and so we can just we could just technically move it into its own repo, and we're not going to break. We're going to try our best not to break it, because you know it is using some kind of weird behavior, but like we're probably not allowed to change that behavior anyway. And then it's just like there, and we don't have to run the test for it. Like, you know, it's just some external code we don't care about. Caffeine Counter has a comment. I think a code review is going to move closer to alignment between people and less about code. It's reasonable for LLMs to continue writing PRs as requested, but does that PR align with the OSS maintainers' vision? And Sweaker463 says, I hope this is the right time to ask this question: how to start contributing to PyTorch in specific, Torch Titan or Torch.io, etc. Sweaker, I'm going to answer your question later. But Caffeine Counter, yeah. So I like... I wrote a blog post about this, right? About human alignment. But I'm just so worried. Like, why am I worried? I'm worried about... So here's what I'm worried about. So first, I'm worried about breaking downstream users, right? So I'm worried about especially like we call them SEVs, right? So when you cause a major outage in Meta, you get a SEV. Google has a thing, they're called OMGs at Google. And yeah, like this is very disruptive. Like you're gonna waste a lot of people's time if you break something. So like and you're gonna get reverted, because like that's just how it works. And for downstream people, like, I mean, it's also consequential. It's less consequential in some sense, because if, you know, like a new version of PyTorch isn't working for people, they'll just downgrade to the other version. But like, you do too many of these and you lose people's trust. Like, hey, this library keeps breaking. I mean, we kind of do break people a bunch, actually, and I feel bad for this. And this is why I feel less comfortable about like not reviewing anything. The other thing is like you know, permanently having to maintain things. I also just worry about like ability to continue making changes. Irreversible. Like basically like, yeah, a lot of features, you know, a lot of the review pressure is on like, if we add this, we have to do this forever, and there's no going back. Like, you know, the system is a ratchet in this way. And so that's why it's important to like make sure you spend a lot of time on it. Kevin Counter, yes, I did read that, and based off my reply off that, I agree with your post. Yeah. So So like, is this the only thing I'm worried about? I'm also worried about like smaller worries, like dumb mechanical problems, like someone forgetting a ref count somewhere, right? Like that are difficult to debug. Some problems are like obvious and you can just fix them, but like uh some problems like are very difficult to debug and it's better to catch them in code review. E.g. ref counts, locking. That's another one is like, maintaining a coherent design, right? So basically like my overall philosophy for software has always been like I want to like have intuitively an idea of how it is supposed to work. And if someone proposes a change and it just like intuitively doesn't make sense, then I'm very, very reluctant to like start pasting things in that direction. So I'll give an example of this. So we've been recently like grappling with in the compiler like how to deal with serializing device meshes and process groups. So the problem here is essentially if I have a program that calls collectives and I want to like serialize that program, the conventional way that this is represented in the IR is that there's a name associated with the process group, and so that name is just sort of hard coded in the call to the collective, and then there's like a global registry that tells you where the collective goes to. And the problem is that these names don't necessarily agree across all ranks, even though like in morally they're the same collective. And so we had a proposal where someone was like, oh, what if we add an alias table to the collectives so that when the collective, when you hit a name and you don't know what this name is, I'm going to like rewrite it to the correct name for my thing. I just looked at this and I was like, okay, I agree this will work, but this doesn't make any sense at all. Caffeine counter. I think read libraries and even OSS in general, having a plugin extension system makes way more sense that even with AI. No more PRs, no more repos, only PRs to manage plugin API. Yeah. So like another answer here, right, is especially with the descendants tangles, is can we debundle PyTorch so that it is a very small core? And there are like mechanical problems to doing this. One of the big ones is C++ ABI. And the other one is monorepo CI issues, right? The C++ ABI one is simple. It is that it gets exponentially more complicated to maintain external extensions if they are C++. So this kind of pushes you in the direction of Python only, but that limits you a lot on how much you can actually debundle. And the other problem is that I guess you could put all of these things in the same repository, but like if you have them in separate repositories, which is like good, like especially okay. So one problem is that like the traditional model for code review says that like everything that goes into the PyTorch repo has to pass all the CI and has to be code reviewed by one person, right? And if you want to do one of these plugin things completely vibe coded, it's much better to have it in another repo because you don't have to ask permission to make a repo and you don't have to, you don't have to do code review on that thing. But the problem is like if you want to not be broken by changes in PyTorch and like if you're only relying on eager mode APIs, you probably won't get broken. But if you're relying on like compiler APIs, which are kind of a mess and like, sort of just evolve like as we go, like, yes, we are probably going to break you because like, it is that fast moving. And that's another problem with like the extension. Here I have a lot of Jax envy because Jax was smart and they separated their package into the C++ one and the Python one, and so that's very nice. Although they're trying to solve a different part of the problem space here because Jax does have an eager mode, but no one uses the eager mode for anything real, and PyTorch eager mode is definitely used for real, and like the overhead reduction stuff we've done for that is in fact very important. in that situation. All right, I lost my train of thought. What am I thinking about? So I code review. So it's Voodoo. Everyone, you always have to do it, and like that's the default, and like the gravity is there. That's what the culture is. We also do it so at least one other person understands the code. We do it to prevent malicious code, mostly from WSS people. Like code review is not going to be a very good way of preventing malicious code for a from a team member, because I can approve it and they can push a change which has the exploit payload and then get it in after that. Like a very, very imperfect mechanism for that. And then we said it's human alignment, especially design, right? Like, so this is a very like, code is just a way of communicating the design, right? Like here is like okay, catch bugs. But this one is like it's not super important what exactly the code says, especially like if there's a bug, but the bug is like superficial. It's just like you change the line and it's fixed. Like the only reason I want to catch bugs like that is because it might be very expensive to catch a bug like that in production. PyTorch, why are you so complicated? All right, let's play bingo. So, how you're thinking about the problem, AI coding, writing prompts. Typing code is slow. It's not the main value add. We're doing these things. Doing code is about reading the code, understanding, doing experiments. Very, very worried. Very worried about increasing code review cost. This is like partially a social norms problem. It is unacceptable. Send code and you haven't reviewed yourself. Is it? Junior or senior? Like, actually, I would love to say, hey, you're not allowed to send in code that you haven't reviewed yourself. But like, does this actually help? Because like, one of the reasons why you're calling in a senior reviewer on the code is because like especially your junior, like take an E4 or something like that, right? You just don't have enough context. You don't really know like why things are this way, how the system is put together, like what the architecture is, like all that stuff is like a big mystery to you. So like when you think about like work should go to the person who is most capable of doing it quickly. This is like definitely like the senior can like review the LLM generated code way faster. But problem. Super inefficient ping-ponging review back this way. Right? So like this is the no more junior hire problems. Which is that like it takes time to actually like soak in the system enough that you can understand all of everything that needs to be done. And yeah, like what is the most efficient way to get there? And this taps into the like LLM learning problem, right? Like learning as a struggle. Like you're just not going to learn as much if you have a problem and then the senior engineer comes in and like solves it and then you like read over the solution. Like that is just not going to result in as good a learning experience as if you were actually trying to solve it yourself. And then this is like when I'm like when I have juniors and then like I put them in the project, like a lot of it is about like just, yeah, I don't really care about getting this thing done quickly. It's just instructive. Like you're gonna learn a bunch doing it. And like I don't do this that often these days, but like back when I was mentoring juniors, like it's like checking in very frequently and like, because it's an alignment thing, right? Like, you don't want like you want to align frequently. This is like the Claude Code lesson, right? The Claude Code lesson is that yeah, full vibe coding is cool and like, it's definitely fun. But like if you're going to like actually like own the code that Claude generates, it's much better to be like involved every patch that is going on so that you can like steer it the way you want it to do. And same with the humans, right? Like don't have this human go off for like a month and like try to figure out a lot of things and like just not be connected to the like you want to be steering them along the way, and you can you can save them a lot of time, and B, like that you're way less likely for them to end up in some weird place and you're like no, you gotta go get away from there, that's not the right place to be. And then this is where the communication overhead and like you want someone who's good because you don't want to waste time on this. Okay, Nokangie says, probably you don't want to change big chunk of code with LLM. You would use it locally within a specific function. As I believe we won't change software architecture of code with LLM, so probably it won't increase the time. Well, that's the thing, right? So like, it used to be that like making a 2-line change might take a while because you got to spend a bunch of time understanding how this isn't put together, and then like what is the exact thing you need to put together to like make the change on the system you want. And with LLMs, the LLM can do all of that, and then it like blorts out 10 lines of code and it seems to pass the test, and you're like, well, why does it work? And then as a junior engineer, you might be very ill-equipped to answer that question. And this is like sort of the problem. This is the code review apocalypse. Like basically the senior engineers are going to like it used to be that the junior at least had to struggle a bit, had to like spend a few weeks like understanding enough about the system to actually generate those 2 lines of code that worked. But now the LLM can just do it in an hour. And like now what? Right? Like so you've like totally increased the amount of incoming code reviews that need to happen, and like it's just not going to work. Open source is cool, and like I can review a lot of open source changes, but usually it's because they're superficial. Like they're just not deeply interacting with the system. It's just like, oh yeah, like sort of shuffling the deck chairs around here, and that makes it easy for me to review them because I'm like, okay, it's fundamentally not doing something all that complicated, and so I can do it. But a lot of the changes that like I do want to do, like the most valuable changes, or at least the changes that I am differentially most capable of doing, are the ones where I'm like, actually, like this system invariant is wrong, and I'm going to change the system invariant to a new one, and like that's the change I'm going to make. Or there's like no system invariant, but it's like completely Let's write this in the system invariance section. The system invariant is wrong. There is no system invariant. Senior engineer. It's about making about adding the system invariant. Like we know LLMs like can't do this today because like they'll just give up. Like if it gets too hard, they're just not gonna understand how to like keep going on a problem like that. Oh, this blog post is a mess. Caffeine counter. I disagree with this argument, or rather that like it speeds up a completed competent junior's learning rather than taking away the learning. Yeah, so like you can definitely do it well, right? Like it's just like the, you know, like LLMs in school like debate, right? Like you can do it well. You can use the LLMs to help you go deep into subjects that otherwise would have been like very difficult for you to go deep in. And like I have definitely like benefited a lot from LLMs when learning new things. And you can also ask it to do your homework, and then you like, you know, you have no longer done your homework. Caffeine Counter says the invariant is like a latent thing in the senior position. I think an LLM assisted PR is the fastest way to get to that point. Well, so yeah, so once I figured out what the invariant is, and I figured out why it's not true, so I do agree that there's a lot of mechanical things involved with like in like adding an invariant that an LLM can assist with, right? You're like, okay, this is the thing I want to do. Go ahead and do it. Run all the CI. Figure out what's going on in the CI. Tell me what you learned. You know, like, oh shoot, well, like this means we have to do a rewrite of this system. Like, I'm very pro LLM on that sort of thing. But I just you're not going to one shot it. Like there's kind of a conversation that needs to happen with the LLM when you're doing something like that. Because the like process of adding an invariant to the system is a dialogue with the code base, right? You're like, I think it should be this way, and you try to make it happen in the code base, and the code base says, no, you can't do it this way because X, and then you have to like look at X and like sort of make a decision about what to do. I guess an LLM could figure that out, maybe, but it could also like make a decision that's not the one you want to make. Like at some point, like some of these like design questions are like the ones that like, you know, we have a bunch of people in the room and we're just like trying to figure out what to do, and like there's just no correct answer, right? Like if you are designing a compiler IRR for deep learning and you're trying to make a decision whether or not control flow should be in the IR or not, right? Like this is a very difficult question. And it's so difficult that we built two versions of the system, one where we did and one where we didn't. Caffeine counter. My point was a different one, in that say your PR passes based on your understanding, passes existing test cases, but doesn't satisfy a design decision that can't be represented as a test, but will be caught in a review of some senior. Yes, that is correct. And like, I also think that it's way... So there are some things that you're going to lose relying on LLMs, like sort of like working over the code to like learn things about the code. But there are also like a lot of benefits, right? Like if you are able to write the code faster, you can get it to the senior faster, and the senior can give you data. Happy New Year, everyone, on the East Coast, at least. That's where I am. I can hear some rumbling in the distance. And yes, and that's good, but that is subject to the assumption that you actually can, like your senior engineer isn't completely swamped by all the PRs, which, well, so I'm thinking about my life, and I am kind of swamped all the time, but it's actually more, the bigger problem is that like the juniors can't update quickly enough. Like there's some PRs where it just takes like a week for them to do another update, and it's just bad. Like that's bad. Like speeding up the like iteration time there would be much better. Caffeine counter. I would say an LM assisted PR is the fastest way to get that snag over coming to that decision yourself. Yes, I agree. So like in the limit, if it like every like change is instantaneous, well, no, but the point is, okay, so caffeine counter, I kind of agree with you, but another problem that I have is like if it's really fast to make the LLM assisted PR, then like why am I not just doing it myself? Like if the junior engineer is not in a position to like sort of understand the deep design problem, and like the only thing they can do is like superficial stuff, but like, you know, the LLMs are getting better, and like, you know, most of the time, yeah, like when I ask it to do stuff, like usually there's not really that many like difficult things to deal with, right? Like, why have the junior engineer at all in the first place, right? Like, I can just prompt like instead of spending an hour reviewing APR that's very long and doesn't do all the correct things, why don't I just prompt the LLM, right? And I get a super fast feedback. I can get it to line up exactly the way I want it. Like, this is kind of like one of the things I was thinking about with GH Clerk. I'm like, hey, like, what's the like what's the point in ping-ponging like easy mechanical changes? I should just fix them myself. I don't like, what's the point of the round trip? There's no reason to have a round trip. Having counter, I think the idea is that you're both aligned on the problem to solve. So you're spending time getting to that alignment, but to identify gaps, you're reaching a stage on the review. Sometimes it's pretty clear what the problem you're trying to solve is, but how to solve it, that's where the problem is. But like if you're getting aligned on how to solve the problem, well, yes. So like getting aligned on how to solve the problem, like this is like kind of the like a very very stereotypical conversation you'll have between a junior and senior is the junior will do something and they'll kind of like understand like the tactical considerations because they had to write out the code and get the test to pass. And the senior engineer is like, oh, but what if you do X instead? And the senior engineer doesn't really know what the tactical considerations are because they didn't actually like run any of the code testing, right? Um, and so like the junior can try it and it's like, oh, but that didn't work because of why. And then, the senior engineer has to update and then like, make a decision. Yeah. So LLMs as humans, right? Like I want to be in a place where the junior engineers can just do this and they don't have to talk to me. But it's just like, is that true? Why do I review senior people's? Well, when I review senior people's PRs, it's because I want to know what they're doing so that I can adjust my worldview. This is from my blog post. IDK. Caffeine Counter says, IDK. I see both pros and cons. I think for a competent junior, it feels like the right way. I think they learn faster and become more efficient quickly. Definitely not the norm at scale. Yeah. I mean, what do I want to say here? So we joke a lot about like 10x engineers on Hacker News, right? Oh yeah, this 10x engineer, like so obviously like such a big difference, and then people are like, oh no, does it really exist? Like maybe the 10x engineer is just 10x slop, but there definitely is a difference. Like I work with people who are like really really good, and you can tell it's very obvious. And I work with plenty of people who are fine. Like I'm like they're net positive. I'm happy to have them around. I'm happy to like help them with their code and code reviews and stuff like that. And sometimes they're very early in their career, and so it's like, oh yeah, maybe I'm investing in them in hopes that they can become more senior over time. And sometimes they've been around for a while, and it's kind of like, well, he's this guy. They do this, and like that's what I get, and it's still net positive, but like, yeah, they're I mean, it's not fundamentally going to change, and this is still useful because like there's just some places where like you can use some sustained attention, and yeah, it's not the crack shot, but that's like not everyone can be a crack shot. Like it's very rare. All of them have gone to do AI startups. Oh no, no, it's senior engineers things they are looking for. This includes like making sure you can't do bad things with APIs, make legal states unrepresentable. Understand the implications. How will it be used? How can it be misused? I actually think for these, a reasonable prompt can work. It's just mostly it's a false positive issue. LLM flagging way too much stuff and reducing signal. Kevin Counter. I think a better example would be someone who's picking up a new code-based language but has the experience. I think they'd have good intuition on a new code base and ARC pretty easily, but would probably take longer without LLM to hit the same snag, where they'd hit up a colleague for some code-based specific nuance. Yes, like absolutely, right? Like if you have someone who's good but just isn't familiar with things, like I think LLMs are a huge game changer here. Like yeah, if you're like a senior engineer and you're like, oh yeah, I'm afraid of moving because I have all this implicit knowledge that like is specific to my thing, and I like can I transfer it? And the answer is well, yeah. In the age of LLMs, you absolutely can transfer it. But this is not most real junior engineers are not this, right? Like yeah, this is also like the thing where like some people boast, oh, I have a team and it's only senior engineers and it's great. Like I love it. And that's, I mean, yeah, it is nice to be on a team with only senior engineers. But is it an instrumental goal for me to help the juniors out? Do I care? I mean, I think I care a little. Normally so this is like one of those big company distortion things, right? Like in a big company, at least traditionally, there's like a pretty robust junior hiring pipeline. And so you just end up like your headcount just ends up getting filled this way because it's just very hard to hire senior people. So I also kind of care in an instrumental sense. Like that's the people I will tend to get. There's a comment. Cap and counter. In those cases, I think it's faster to just start setting PRs with confidence IMO, and I give juniors a chance at the same playing field. Yeah, sure. But like I don't mind. So one of the like characteristics of someone who's senior and ramping up is they're going to send a PR that's like relatively short to start with, right? And like if they start working on something that's very big, they'll be like checking in with you a lot. They'll be like, oh, yeah, I'm working on this big thing and I don't really know if it's a good idea. Or, if they're like trying to just prototype something out, they'll be very clear. They'll be like, oh yeah, like I wrote this code. I don't really care about it. Like, you can tell me to redo it in any way you want, but like, I was just trying to figure out how to make it work. And they'll tell you all these things in their own volition. Like you don't have to like pull it out of them, like pulling teeth. Like one. This is one of the like big for me distinguishing characteristics for junior versus senior. The seniors talk to me all the time. They're like, oh yeah, yeah, I'm trying this thing, and I don't know if it's the right thing, and they'll like do constant communication. And the juniors, not a peep. Like I only hear from them because they want me to review their PR, and I'm like, ah. Caffeine counter. Oh, for sure, haha. But I don't think that ASIC chains read LLMs or otherwise. No, it doesn't. It just means, yeah. Yeah. I don't know. There's a big ball of everything. There's so many variables here. Test community. So another thing is like with LLMs, kind of write a lot more tests. Over testing is a big problem with their conversations. And this is like a $1 million question in and of itself, and I really don't know because I've never been able to solve it for PyTorch. Like our test suite just gets bigger and bigger, and then we like do things like target determination. And it's like choosing what to stay and what not, like very difficult alignment problem. Like I think LLMs can help with a lot of mechanical things, but like actually making the value judgments about like, yes, I do not need to test this thing because like I don't think it'll actually make a difference. Like I just think it's very hard to outsource that to an LLM. Is that true? Maybe it can do a good idea. Like maybe we can figure it out from the code. Another thing is the senior engineer design stuff. LMs are pretty good. Like if you're worried about like bothering a senior engineer a lot about design problems, like if you do the LM first, like it's really good actually. Like especially comprehensiveness. This is like the old chestnut in the interview where like you're like looking for them to check off all the things in the design question, and all of them can reliably hit all of them. And then it's useful, right? Like just actually thinking about everything you have to worry about is useful here. No Kangia. I saw today a course from Stanford, the modern software.dev. Maybe it would be interesting. The modern software developer. Oh yeah? Let's see. What's this? Well, who's this guy? Oh yeah. Yeah, this looks like a 2025. Where's the syllabus? Here it is. Okay, intro, coding agents, AI IDE, coding agent patterns, terminal testing, modern software support. Alright, so they got some code review stuff. Automated UI, agents post deployment. What's next? This is probably a fun lecture, but I don't know. I don't know what that is. These are like very old code review essays. I wonder what this one is about. That seems like an interesting YouTube video. Hey, they got the CPU from Graphite. Yeah, so they're talking about code review. Oh, this is a very boring slide deck. That's this paper. 2024. Ancient history. Yeah, I don't care. 2024. Obviously written by Claude. Lol 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 lol. Let's see. I'm thinking. some other stuff to worry about. Debuggability. Observability. Understandability. Especially if you're having a production incident. E.g., why not to rewrite code into assembly? A well-trusted test suite. E.g., the Simon Willison post about that HTML parser in Python. Like the thing about having debuggable code is I am pretty sure you can prompt it. I don't think the LLM will write it this way by default, but like if you know how the observability should work, that way. So this is a good example of embodied intelligence, because it's hard to tell people how to write observable code. Instead, it works a lot better to force people to try to look into the code in the large production incidents, and that is the most reliable reward signal for getting people to do better writing their code. But maybe you can write some prompts that will get that to the LLM. And there's also like accountability. And ask the LLM to join debugging instead. I mean, you can, but like that's not the accountability you were looking for. The self-review thing was in the Oxide post. Well, I thought they had one, but I don't see it. Hey, Mark. We've been talking about all sorts of random topics. But essentially, like the question is, what does AI coding mean for PyTorch, for open source, for superintelligence? Happy New Year, Mark. Yeah, it's I'm East Coast, so it's already the new year. Yeah. So like there's a bunch of stuff like how it relates to code review, increasing code review cost, tests. What is the function of a senior engineer? How are juniors related to that? You know, how do you align? Like what exactly does it mean to like build software? What does it mean for software to be successful? Um, is the embodied AI problem what the big barrier to AGI? Um, is there a way to set up a library like PyTorch so that you don't have to do code review, modularity, and then some stuff about debuggability of AI generated code? Like, the thing is that, like, it's just not that valuable to have a human who is deeply familiar with the exact source code in a SEV, because that person might have left the company. And in any case, most of the problem is getting to the root cause of the problem, right? So, like, most of the, like, what is a SEV? A way to pull the right people together, right? Like, when you're working on a, like, super huge, like, company infrastructure like at Meta, right? Like, the problem is mostly that, like, the actual service degradation is owned by some, like, very downstream team, and they don't know all the systems they're using, and they need to figure out who to actually send it to. And sometimes it's easy, but most of the time it's not. And when it's not easy, most of the time gets spent trying to get it to the right spot. And once you've gotten it to the right team, usually it's very quick to, like, actually be fixing. But, like, getting it there, that's, like, usually the tricky bit. So many Twitter notifications. I think I'm all tapped out. I'm not really close to a blog post. I'll just sleep on it. Any parting words from folks who are listening in? Mark says, we need a more positive vision of the future, then we will fire all the engineers. Ha ha ha. Do I think Meta is going to fire all the engineers? But they're not like, I mean, they can do layoffs, I guess, but, like, they're mostly going to do it through attrition. They're going to do it by not hiring people, because, like, they will look at and see that at a high level systems level it's just not necessary to have that many people. It's kind of like how Elon Musk fired all of Twitter, right? And Twitter's kind of like, you know, still working. It's a really interesting comparison when you compare, like, vibe coding LLMs, and, like, I'm an exec and there's some software teams and they're, like, doing stuff, and I'm, like, very, very indirectly doing things. Kevin Counter says, I mean, the thing with Twitter is that the product was solved. Yeah, I think so. They basically don't have to, like, change anything. And, like, you just have to, like, keep the production system humming, which, like, I guess is requires some people, but doesn't require a lot of people. Kevin Counter says, I wouldn't attribute that as a win for the decision. No, I guess my point is that, like, at a high enough level up the management chain, right? Like, you're not looking at the code, right? It's very, very, your control over, like, what is happening is very indirect. I don't really know much about this because, I mean, I have gone off the chain a little, but I still read code. Yeah, these days, like, lots of people send PRs, and sometimes I just don't. I don't read the code in the PR. I just, like, read the description. I'm like, does this make sense from the system? And I don't need the code to, like, make sure it makes sense in a system design perspective. And I'm trusting that, people are, like, reasonably aligned and they'll make good local decisions. And then there's places where it's, like, difficult. The questions. The $1,000,000 question. Can I fire all the engineers? Okay, questions. Can I? And this is not $1,000,000. This is a lot more than $1,000,000. What's $1,000,000 of head count? It's like one person, one head count. It's so little. Engineers are so expensive. Can I stop code reviewing code? How should I re-architect PyTorch so things are better or easier? How would I do it? Scratch. What should I force people to do? What should I tell people to do? What should be in my prompt? How many tests should I have? There's one more I wanted to say. I don't remember. Mark Sauerfein says, IDK on code review, like, is the future full re-implemented artisanal dependencies? The LLMs are like using popular dependencies. But this is like already how PyTorch works, right? Like we try very hard. We try very hard not to like add deps, right? And a lot of deps like we added, like I've added reluctantly, and we can like kick them out and just inline the code using LLM. Pay to win. Big companies paying for getting included in the dependency list. Lol. I need to change the profanity filter on my stream. Okay. Let's call it a wrap. Thanks everyone for joining. I don't have answers, but I don't know. I'll sleep on it. All right. Thanks for joining. Makes me feel less alone puzzling through these problems. See you all next time.